Let's start with something basic, yet incredibly important. What exactly is matter? Take a moment. Look around you. The air you're breathing, the water in your glass, the food on your plate, even you, are all forms of matter. In the simplest terms, matter is anything that has mass and takes up space. From towering mountains to invisible gases, from metals to milk, if it weighs something and occupies space, it's matter. And this is where chemistry begins. Because understanding matter is the first step toward understanding everything else. Let's explore how matter shows up around us. It exists in three classical states, each with unique characteristics. Solids. Their particles are packed tightly in a fixed, orderly structure. That's why solids have a definite shape and volume. Think of a brick or an ice cube. Liquids. Here, particles are still close but they can slide past each other. Liquids have a definite volume but no fixed shape. They flow and take the shape of their container like water in a glass. Gases. Particles in gases are far apart and move freely in all directions. That's why gases have no fixed shape or volume, they expand to fill any space they're in. From the hardness of a rock to the flow of milk and the air you breathe, matter is all around you, just in different states of motion and structure. Here's something fascinating. The states of matter are not fixed. They can transform into one another simply by changing temperature or pressure. Solid to liquid, that's melting. Liquid to gas, we call that vaporization. Gas back to liquid, that's condensation. Liquid turning into solid, that's freezing. And when a solid skips the liquid phase and becomes gas directly like camphor or dry ice, we call it sublimation. You see this chemistry in action every day, ice melting in your drink, water boiling into steam, or frost forming on a cold surface. These changes might look simple, but they reveal the dynamic nature of matter. Now, here's something a bit beyond your syllabus, but still worth knowing. In addition to solids, liquids, and gases, there are two more exotic states of matter. First is plasma, a high-energy state where atoms lose electrons. It's found in stars, lightning, and even neon signs. Second is Bose-Einstein condensate, an ultra-cold state of matter where atoms come so close together, they behave as a single quantum entity. It's like making atoms march in perfect unison. Fascinating, right? For now, we'll focus on the three classical states, solid, liquid, and gas, the foundation of everything in chemistry. Let's now compare the three classical states of matter, solid, liquid, and gas, based on their physical properties. Shape. Solids have a definite shape, they hold their form. Liquids, on the other hand, have no fixed shape, they take the shape of their container. Gases also have no shape, they spread out and fill any space available. Volume. Both solids and liquids have a definite volume, they occupy a consistent amount of space. But gases? Their volume is not fixed, it expands or compresses based on the container. Compressibility. Solids are almost incompressible, their particles are tightly packed. Liquids can be compressed slightly, while gases are highly compressible since there's a lot of space between their particles. Particle motion. In solids, particles only vibrate in place. In liquids, they move moderately, sliding past each other. In gases, particles move freely and randomly in all directions. So, as we move from solids to gases, the arrangement and behavior of particles become less ordered and more dynamic, explaining why each state behaves so differently. Until now, we've looked at matter by its state, solid, liquid, or gas. But there's another way to look at it, by its composition. What is matter actually made of? All matter around us can be broadly classified into two main categories: pure substances made of only one kind of particle. These have fixed properties and composition. Mixtures made of two or more different particles physically combined. So, whether it's the air you breathe, the salt in your food, or the gold in a ring, it all fits into one of these two groups. Let's dive deeper into what sets them apart. So, what exactly is a pure substance? Simply put, it's made up of only one kind of particle. It has a fixed composition and shows definite, consistent properties no matter where you find it. Now, pure substances come in two forms: elements. These contain just one type of atom. Think of copper, oxygen, or gold. Each is made of identical atoms. Compounds. These are formed when two or more elements combine chemically in a fixed ratio. Examples: water and carbon dioxide. And here's the key: pure substances can't be separated by physical methods. You can't filter water into hydrogen and oxygen with a sieve. It takes chemistry to break them apart. Ready to explore mixtures next? Now, let's talk about mixtures. A mixture is formed when two or more pure substances are combined physically, not chemically. And depending on how they blend, mixtures come in two types: homogeneous mixtures. These looks uniform throughout. Think of salt dissolved in water or the air you're breathing. You can't see the individual components. Heterogeneous mixtures. These are clearly non-uniform. Like a salad or a mix of sand and iron filings, you can spot the parts with your eyes. What's more, mixtures can be separated using simple physical methods like filtration, distillation, or even hand-picking. No chemical reaction needed, just a little clever sorting.